Asalam-o-Alikum and welcome back. So our today linear and non-linear correlation. So what is linear correlation? Correlation is said to be linear if the degree of movement in some variable has a constant ratio to the amount of change in the other variable. For example, if 10% increase in prices each time, so the demand decreased by 15%. So there should be linear correlation between two variables. But such type of correlation are found in exact science like physics, chemistry, etc. Another example of linear correlation is that if the amount of output in a factory is doubled by doubling the number of workers and varies in quantity in proportional to the increase or decrease in the number of workers. The next one is curvilinear correlation, or we can say non-linear correlation. So correlation is said to be a non-linear correlation if the ratio of change is not constant. In economic data, the ratio of change in two variables is usually not constant. So the next topic is about scatter diagram. So what is scatter diagram? When two related variables are plotted on a graph in the form of points or dots. So the graph is called a scatter diagram. So there are some types of scatter diagram. We will draw each of them one by one. As we already discussed in the previous lecture about scatter diagram, so positive correlation or negative correlation. So we will draw the graph. What is the positive correlation? So for positive correlation, we can draw the scatter diagram in this way. So this is what scatter diagram is. Of positive correlation. For positive correlation. The next one is, and in this diagram, this is y-axis, which is dependent variable, and x, which is independent variable. This is x-axis, this is independent variable, and y is the dependent variable, and this is the origin. Next one is about negative correlation. So for negative correlation, we have the scatter diagram in this way. When the one is increasing, the other will decreasing. As if we consider on y-axis there is prices, so the demand and the quantity on x-axis. So as the prices increases, the quantity will decrease. So there is a negative correlation between both of the variables. So this is negative correlation. On the other hand, in positive correlation, when the prices increases, the quantity also increases. So that one is about positive correlation. And this is about the one we draw right now is about negative correlation. So this is negative correlation. And we already discussed about the curvilinear, or we can say a non-linear correlation. So for that we can draw the graph like this. curved linear correlation. So for curved linear correlation, we can draw the graph in this way. So this is about non-linear correlation, or we can say curved linear correlation. So this is about curved linear correlation. The next one is zero correlation. This is y-axis and x-axis in this graph, and this is about non-linear correlation. Now we will draw about zero correlation. So for zero correlation, we have y-axis and x-axis plane, and there is zero correlation, so we can't draw any line. This is about zero correlation. No correlation. This is zero correlation. Zero correlation. The next we discuss about the coefficient of correlation. So the coefficient of correlation is a measure of the degree of interdependence between two variables. So the coefficient of correlation is measured by R. It is a pure number and varies between -1 and +1 with a central value 0. So when R equals to 0, it means that there is no correlation between two variables. For measuring the exact degree or trend or direction of correlation, Carl-Pearson method is the most satisfactory method, and which is So we take the formula, which is R equals to sigma summation x minus x bar, and we already know how to find x bar. Sum of observation divided by number of observation is about x bar, and y minus y bar, y minus y bar divided by whole divided by number of observation, which is n, with sigma x and sigma y. Uh, the next formula for this is summation dx dy divided by number of observation sigma x by sigma y. So the deviation of individual x value from their mean is about dx. What is dx? So dx is the deviation of individual x value from their mean. And what is dy? Dy is the deviation of individual y from their mean. N is the number of pairs of values. Sigma x is the standard deviation of x values, and sigma y is the standard deviation of y values. So for this we find how to find sigma x or sigma y. So for sigma x, we have the formula summation x minus x bar whole square divided by n, or we can say this is equals to square root summation d square x summation d square x by n. Similarly, sigma y is summation y minus y bar, because this is about y. So y minus y bar whole square and divided by n, or we can say that summation d square x d square y, not x, sorry, divided by n. So these formulas is also known as Pearson product movement correlation coefficient. These are formulas. So the next slide is about degree of relationship. So the correlation between two variables may be of the varying degrees. It may be perfect positive correlation. For example, R is equals to plus 1, which is perfect correlation. And when there is perfect negative correlation, it means the R value is equals to minus 1. So a limited degree of positive correlation, for example, less than 1 but more than 0. This is a limited degree of positive correlation. And limited degree of negative correlation, for example, less than 0 but more than minus 1. And no correlation means R equals to 0, or we can say zero correlation. Now, what are the properties of the correlation coefficient? R is symmetrical. For example, Rxy equals to Ryx. R is the geometrical mean of the two regression coefficient. R is independent of change in origin and unit. R lie between minus 1 and plus 1. For example, R is between minus 1 and plus 1. The lowest value is minus 1 and the highest value is plus 1.